simplifying systems of linear equations. And in this section, we are going to discuss the 5 methods for solving linear equations that we've gone over so far and when best to apply each one. The first thing that we covered was graphing. Now, graphing is best used when you need to estimate an answer and you don't need something very precise. Now, I know a lot of the questions that you get from the textbook, they have small numbers, they're easy to line up and to get a precise answer with. However, in real-world situations, unless you're using a computer, there's very, very detailed analysis. Graphing by hand is basically going to give you an estimate at best. Now, the next thing that we covered was substitution. Substitution is what we use if, when we look at either of the equations, if we have a variable that has a coefficient of 1 or -1, or if it's just a variable alone, in which case the 1 is understood. Specifically, if you have something such as x equals or y equals, what you're going to do is you're going to take what x equals and substitute it for x in the other equation, or take what y equals and substitute it for y in the other equation. Next, we have elimination by addition and elimination by subtraction. So for this, you're either adding or subtracting the equations, and you're doing this with the purpose of canceling out a variable. So how do we know when to add and when to subtract? You add if one variable has opposite coefficients in the two equations. For example, if I had a 3x in one equation and a -3x in the other, I would add the two because 3 and -3 equals 0. It cancels. Subtraction is what you use when one variable has the same coefficient in both equations. For example, if I had 3x in one and 3x in the other, I would subtract because 3 minus 3 equals 0. And the last method that we reviewed was elimination by multiplication. Now, if none of the coefficients are 1 or -1, for example, if we don't have it in y equals format or x equals format, so we can't do substitution, and neither variable can be eliminated just by adding or subtracting as is, that's when we are going to multiply. The purpose of multiplication is to make it so that the coefficients are either opposite or the same, so we can do elimination by addition or subtraction. So now let's take a look at some examples. So with this system of equations right here, we can see that with the y, we have the same exact coefficient. Now when we have the same coefficient, we're going to solve this using subtraction, and specifically when we subtract 7y minus 7y, we end up with no y's. So to do this, 5 minus -2, 5x minus -2x, remember when you subtract a negative, that's the same as adding, so this really becomes 5 plus 2, which would be 7x's. 7y minus 7y, it cancels, and 2 minus 9 is going to be -7. We're going to divide both sides by the coefficient, 7, and we end up with x equals -1. Now, since we have a value for x, we can substitute this into either of these equations. It does not make a difference at all. If we substitute it into the first equation, we end up with 5 times x, which we know is -1, plus 7y equals 2. 5 times -1 is -5, so we have -5 plus 7y equals 2. We're going to add 5 to both sides. We get 7y equals 7, and divide both sides by the coefficient. We get y equals 1. So our solution for this is an x value of -1 and a y value of 1. So now let's take a look at this next one. So here, addition won't work, subtraction won't work. 3 plus 5 is 8, -4 plus 8 is 4, 3 minus 5 is -2, -4 minus 8 would be -12. So either way, we're going to have x's and y's left over. So when addition and subtraction won't work, we move on to multiplication. Now you have two options here. If you wanted to eliminate the x variable first, see how the coefficients here are 3 and 5? I could simply multiply the top equation by 5 all the way across. That would give us 15x. And I could multiply the bottom equation by 3 all the way across, and that would give us 15x as well. Then I could subtract and eliminate my x's. There's also another way that we could do this that's a little bit simpler. Let's look at the y's. See how 8 is divisible by 4? 4 goes into 8 twice. So what I could do is I could simply multiply by 2 and only multiply the top equation. If we do this, let's see what happens. 2 times 3x, we end up with 6x. 2 times negative 4, we have minus 8y. 2 times negative 10, we end up with negative 20. The bottom equation we're going to leave alone. And by doing this, look at our y's. Since we have negative 8 and positive 8, we have opposites. And when we have opposites, we can eliminate by addition. 6x and 5x, that's going to be 11x. Negative 8 plus 8 cancels. Negative 20 and negative 2, that's going to be negative 22. Divide both sides by the coefficient, which is 11. We end up with x equals negative 2. Now, I can take this negative 2 and I can substitute it into any of these 4 equations. Either way, we get the same answer. It really does not matter. So, let's take the third one. 6 times x, which we know has a value of negative 2, minus 8y equals negative 20. All I did was I took this, I substituted our value for x, in for x there. 6 times negative 2, that's going to be negative 12, minus 8y equals negative 20. I'm going to add 12 to both sides. I have negative 8y equals, and negative 20 plus 12 is going to be negative 8. Divide both sides by negative 8, we get a y value of positive 1, because a negative divided by a negative is a positive. So our x value is negative 2, our y value is 1, so there is our solution. And let's take a look at one more system of equations. Now, with this one right here, you should notice right away that the top equation, not only do we have a coefficient of 1, remember if nothing's written there, we can assume that's a 1, but also this is in y equals format already. Anytime you have y equals something or x equals something, you can just jump right to substitution. Since y equals 4x plus 5, what I'm going to do is I'm going to substitute this value in for y in the other equation, in this case the second one. Specifically, I have 2x plus, and now where my y is, I have 4x plus 5, and that's going to equal 17. 2x's and 4x's, that's 6x's, plus 5 equals 17. I take away 5 on both sides. 6x equals 12. Divide both sides by 6, and I get x equals 2. Now that I know what x equals, I can substitute this value for x into either of the equations. I'll use the first. So we have y equals 4 times, instead of x, we're going to write 4 times 2, because that's the value of x, plus 5. 4 times 2 is 8. We have 8 plus 5. And 8 plus 5 is 13. So our solution set, x equals 2, y equals 13. So that is Chapter 6, Section 5, Applying Systems of Linear Equations. See you in class.